Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy semester exams. We are dealing with circuit theory crash course, and today in lecture 10, as a part of lecture 10, we'll be looking at superposition and reciprocity theorems. Before that, let me tell you, I am Y. Shravan Kumar, having 7 plus years of teaching experience and mentored more than 5K students for GATE and engineering services. Also top grade GATE. Now, let me also tell you how to install an Academy Learning app. Type an Academy Learning app in Google Play Store and click on this install. If you are opting for GATE and engineering services, click on this. Then you can also click on this plus. Then you'll have this get subscription page. Good evening, Koteshwar. Good evening, Srinivas. Good evening, Swarnasri. Good evening, Sanjana. Sanjana Mathiv. Good evening, Manasa Jilla. Ganesh, good evening. Welcome to Circuit Theory Crash Course, everyone. Now, you can have these two types of subscriptions, Plus and Iconic. You'll get a dedicated mentor for your preparation. You can use my code as YSK10 to get the maximum discount of 10%, and you can click on this Proceed to Pay. Then you'll have these payment options of debit card, credit card, EMI, UPI, wallets, net banking. Using any of these payments platform, you can get subscription to an academy. Now let me tell you about the Unacademy Combat. Unacademy has bought India's largest fortnightly competition for GATE exams, the best quotations by the best Unacademy educators. It's the greatest combat. The challenging questions are curated by the best Unacademy educators and questions guaranteed to keep the test engaging, challenging as well as fun. Now you have a super fast and fun with real-time ranking. See how you rank against the others with live leaderboard after each and every question, and then you can see the competition with the best, know where you stand among all other contestants, and also you'll get the detailed video solutions by the top educators. You'll get an in-depth solutions for the questions right away after the contest. So you'll have scores, the leaderboard and rating as well as the rewards. So please do compete, conquer and crack it, and compete with the best and amaze and win the amazing prizes like MacBook Air Apple for as the first, and as the second Apple iPad mini and Apple AirPods as the third one. Also win rupees 1000 Amazon vouchers for top 100 rankers. So to summarize, an Academy Combat, it's the largest India's largest fortnightly competition for GATE. The challenging questions created by our educators, super fast and fun with real-time ranking, compete with the best, and get detailed video solutions by the top educators. Register now. It starts on December 16th, 6 p.m. and also win exciting prizes as I have told you. Now, coming to today's topic, we will be discussing today superposition theorem as well as reciprocity theorem. And in yesterday's session, we have discussed Thevenin's and Norton's theorems yesterday's class. In yesterday's class, we have discussed what are Thevenin's and Norton's theorems, and today we'll be discussing superposition and reciprocity theorem. Pavitra, good evening. Ramchandra Kumar, good evening, sir. Good evening, Ramchandra Kumar. Manoj Kumar, good evening. Raju, good evening. Very good evening to one and all, and welcome to Circuit Theory Crash Course. We are today discussing superposition and reciprocity theorem. We are discussing reciprocity and superposition theorems. So let me take up I'll just revise what we have read in the last class, the two theorems, then I'll just move on to the next one. So first let me tell you about the Thevenin's theorem that we have done yesterday. So in Thevenin's theorem, just a recap, it states that if you have a network, if you have a linear bilateral network which is connected to some load, this can be replaced by, you have a load here, it's a network, it's a two terminal network. This can be replaced by a single voltage source in series with a resistance which is connected to a load again. and the value of this voltage source is VTH, and the value of this resistance is RTH. VTH is also called as VOC, and VTH is the open circuit voltage. RTH is the equivalent resistance measured across this load terminals. So VOC or VTH is open circuit voltage or Thevenin's voltage. Open circuit voltage or Thevenin's voltage. And RTH was the equivalent resistance or Thevenin's resistance across terminals across A and B. Across A and B, the equivalent resistance is RTH. So let us look at the other one that we have done yesterday. The other one is Norton's theorem. So Norton's theorem states that any two-terminal linear bilateral network can be replaced by, if we have any network like this which is connected to some load, this can be replaced by, this can be replaced by an equivalent. You are connected to a load here, and this is a linear bilateral network. This can be replaced by an equivalent current source in parallel with a resistance of value Rn and current source value In. In is also denoted as ISC because ISC or In is the Norton's current or short circuit current. Short circuit current. And Rn is the same equivalent resistance that is measured across this load terminals A and B. This is also load terminals A and B. We are connecting a load here. So Rn is the equivalent resistance measured across A and B. Now let us move on to the next theorems. So today we will be dealing superposition and reciprocity theorems. So today we will discuss superposition theorem first. Let us discuss what is superposition theorem. I'll just give you an idea what superposition theorem is. First I'll tell you the statement and then I'll explain you. So what does superposition theorem state is, in a linear network containing more than one independent. Augustus, good evening. Welcome to Circuit Theory Crash Course. In a linear network containing more than one independent and dependent sources, that means a circuit has more than one dependent and independent source. Response in any element. Response in any element is the algebraic sum of responses caused by individual sources. Caused by the individual sources or the sources acting alone. That means let us say you have an element, you have a circuit like this. Let us consider this circuit. Let us consider this circuit which has two voltage sources. Let us call the voltage source as V1, this as V2, and let us take some resistors as R1, R2, R3. Now the question is, let us consider this circuit and let us say the current in this circuit is I. The current in R3 is, let us say, I3. Now what does superposition theorem state is, the response in any element, current in this element because of these two sources is equal to the algebraic sum of the responses caused by the individual sources. That means if you apply V1 alone once to the circuit and find the response. Now, when you are applying only one source alone, V1, the other source must be replaced by its ideal internal resistance, or if a voltage source is there, it can be replaced by a short circuit, and if there is a current source, it must be replaced by a voltage source, short circuit. If a current source is available, it must be replaced by an open circuit. If a voltage source is available, it must be replaced by a short circuit. So I'll just write it. If you have a voltage source, replace it by a short circuit. If you have a current source, replace it by an open circuit. So because we have this voltage source here, I'm just shorting it. Srishti, nice session, sir. Thank you. So this is I3 dash. What is I3 dash? I3 dash is the current because of V1. I3 dash is the current because of V1 dash. I3 dash is the current because of V1 dash. Now in the similar fashion, what we will do is we have considered only one source at a time. V1 is considered first, then now I'm considering V2. That means V1 must be made 0. So this is 0 means this is a short circuit. So you will make it short and find the response in R3 because of the source V2. This is V2 source. When you find this I3 double dash, I will call this as I3 double dash. What is I3 double dash? It is the current because of source V2. Now let me take this in the next slide and explain you once again clearly. Now if this is the circuit, let us say this is the given circuit. Now we have two cases here. We have two cases. Case 1. First you need to identify how many number of sources are there. How many number of sources are there? 2. So how many cases you will get is 2 cases you will get. That is case 1 and case 2. How many number of cases we'll get? We'll get 2 cases. Can I know the application of superposition theorem? Sure. So whenever you have multiple number of sources, the response in this can be known. The response in any element can be known by summation of the individual sources response. So case 1 is, first we will have one source acting. Only one source is acting, making other source replaced by its internal impedance or replaced by making the other source as 0. So we will consider V1 is active and V2 is equal to 0. What is V2 is equal to 0? It is a short circuit. So we will draw that circuit and find the response of, see, because this is V2, it must be shorted, right? So this is a short circuit. So this is R1, R2, R3, V1. Now we will find the response in R3 as I3 dash. So let us say this is the current I3 that we have found by applying two sources, and I3 dash, what is I3 dash? I3 dash is the current because of V1. So we have found the response because of one source. In the second case, similarly, we will apply V2 is active. First we have considered V1 active. Second we will consider V2 as active, and V1 is equal to 0. This is also a voltage source. So we will also make it as a short circuit. We will make it as a short circuit. So we'll draw the diagram. V1 is made 0. So this will be a short circuit. When you make it as a short circuit, when you make this as a short circuit, you will have this circuit like this, and you are applying V2. You are applying V2 plus V2. Now we will find what is the current in this R3. This is R1, R2, and now when we find this current, we will call it as I3 double dash. Let us say we will call it as I3 double dash. So now what I say is this I3, the total current, the response in any element is the sum of these two responses, that is I3 dash plus I3 double dash, I3 dash plus I3 double dash. So this is how you'll do it. So let us take one problem and try to solve this question. Let us consider one, let us take one question. I am taking one question from the one of the standard textbooks, and let us find what is the response. So the question here is, the question here is find the current through, find the current through 8 ohm resistor, find the current through 8 ohm resistor using superposition theorem. Find the current in 8 ohm resistor using superposition theorem. Now the circuit given is something like this. You have a voltage source with a resistance and another resistance. There is a resistor again. There is one more resistor and this is the other resistor, and you have this voltage source. Now let us take this as 4 volts, this as 5 ohms is given, this as 10 ohms, this as 15 ohms, and this as 8 ohms, this as 12 ohms, as well as 6 volts, right? Now let us try to find the solution. The first step that you have to do is how many number of sources are present, and what are those sources. There are how many sources? Two sources. And what are they? Let us name them as V1 as 4 volts and V2 as 6 volts. Let us name them something like this. Let us call this source as V1, this source as V2. Now let us take the first case. The first case is superposition theorem states that response in any element is the equal to the sum of the responses by the individual sources. Now the current in this 8 ohm is equal to the, now let us say this current as I8 that is flowing through this. I will say this I8 total is equal to I8 dash plus I8 double dash. What is I8 dash? Let us say I8 dash, let us consider I8 dash as current in 8 ohm resistor because of V1 alone. And let us call I8 double dash as, let us call I8 double dash as current in 8 ohm resistor because of produced due to V2 alone. So we have to find I8 dash, I8 double dash. Now let us see how do we find that. Let us take this circuit. Now let us consider this circuit. Now let us consider this circuit. Vijay Dhawan, good evening. Welcome to Circuit Theory Crash Course. Welcome to Circuit Theory Crash Course. Today we are dealing with superposition theorem and reciprocity theorem. Now, let us say first case 1. What is case 1? Case 1 is when V1 is active and V2 is equal to 0. That means source is made short circuit, right? So now when you do that, this will be V4 volts will be active, and you have a resistor here, another resistor. So this will be, now this is because voltage source V2 is equal to 0, you have to make it a short circuit. Now let us write this. This is 5 ohm, this is 10 ohm, this is 12 ohm, 15 ohm, 8 ohm, and this is 4. Now you can use any method. I'll just try to take Mesh analysis, let us call this as I1. This current, randomly you can take any value. Let me take this in this direction, this as I3. Let us take this as I3. Now write the equations. When you write these equations of Kirchhoff laws, apply mesh analysis here. When you apply KVL to this loop 1, let us call this as loop 1, this as loop 2, and this as loop 3. So you will get 4 is equal to 5 into I1 plus 15 into I1 minus I2. That is I1 minus I2. Similarly, you don't have anything else. This is the first equation. Or you can simplify that and write as first equation. You just simplify that. 15I1 plus 5I1, it is 20I1 minus 15I2 is equal to 4. This is the equation number 1. Now let us try to find what is the second loop equation. It is 15 I2 minus I1. Here 15 I2 minus I1 plus 10 into I2 plus 8 into, you have 3 currents here. What 3 currents you have? What is that current? 3 currents? Sorry, in 8 ohms you have 2 currents, I2 and I3 current. What is that? I2 minus I3 is equal to 0. You don't have any source in this. Let us simplify this. This is 15 I2 minus 15 I1 plus 10 I2 plus 8 I2 minus 8 I3 is equal to 0. So this is minus 15 I1 plus 10 I2 8 I2 plus 15 I2. 18, 25 plus 8, 33 I2 plus minus 8 I3 is equal to 0. This is 15 I2 minus I1, 10 I2, 8 into I2 minus I3 is equal to 0. This is the second equation that we got. Now if you try to apply the third equation, it is 12 I3. You don't have any other current in this 12 ohms plus 8 into, you have two currents in 8, I3 minus I2. So I3 minus I2 is equal to 0. This is 12 I3 plus 8 I3 minus 8 I2 is equal to 0. So this is minus 8 I2 plus 12 plus 8, 20 I3 is equal to 0. So you have got three equations here. No, it is not necessary to take the same direction of current in a loop. You can take anti-clockwise or the clockwise. That doesn't at all matter. The ultimate answer will depend upon the direction of the current. The ultimate answer will remain same even if you take the currents in the opposite directions. But you have to be careful while calculating the resultant current in this 8 ohm resistor. You have to be very much careful when you are taking this current direction in this 8 ohm resistor. Now if I take what is the current direction in this 8 ohm resistor, this is I2 is flowing in this and I3 is flowing in the upward direction. You can take I2 minus I3 because I'll consider this current as I8 dash. If I consider I8 dash and I2 are in the same direction, so you can take I8 dash is equal to I2 minus I3. I8 dash is equal to I2 minus I3. Or you can also solve this by using the other methods, by current division or voltage division methods as well. Yeah, thank you, Vijay. Thank you. It doesn't matter, don't worry. I'll make it easy. I'll also tell you the other method also if you want it. So let's take one by one. The equation is 4 is equal to 20 I1 minus 15 I2. The second equation is 15 I1 minus 15 I1 plus 33 I2 minus 8 I3 is equal to 0. This is 0. And let us consider the next one. This is 8 I2 plus 20 I3. 8 I2 plus 20 I3 is equal to 0. So these are the three equations that you have. You just have to simplify this and find the values of I1, I2 and I3. Once you get these values of I1, I2, I3, you can find I8 dash. I have taken this I8 ohm resistor, this current as I8 dash. In this there are two currents, one is I2 and this current is I3. So I8 dash will be I2 minus I3. You just have to simplify this. I'm just leaving it to you. I want you guys to solve it. So once you get I8 dash, then you have to consider the same circuit and solve for no. So we have, let's say we have found I8 dash. Now we are finding the second one. So in this the total current is I8 dash plus I8 double dash. I8 dash is the current because of this V1 that I have considered. Now we are finding I8 double dash because of V2. Same thing you can do. I'll do this by using the other method. Let's see. Now the case 2 is, what is the case 2? Case 2 is when V2 is active, second source is active, and V1 is equal to 0. V1 is a short circuit. So nodal analysis is easy to solve such problems. Yeah, you can use nodal analysis as well, or you can also use mesh analysis, or also I'm going to tell you the other method also. Let's also do by that method, which will be much more easy because the students are much more familiar with the mesh analysis. I'm just trying to give the basic idea on mesh analysis. You can use nodal analysis, mesh analysis, or you can use network reduction by using the series and parallel combination, and also find that. I'm going to tell you that method as well. Yeah, anything that you are comfortable with is very easy to solve, Vijay. So when V2 is active and V1 is equal to 0, that is short circuit. So let us take this way. Now let us write all the values. This is made as short circuit. If you just look at this V1, this is 5 ohm resistor, this is 10 ohm resistor, 15 ohm resistor, 12 ohm resistor, and 8 ohm resistor. This is 6 volts. Now I'm going to do some other method. Just look at this method. You can use, in the previous case I have done the mesh analysis. Now as Vijay said, Vijay Dhawan, you can also do nodal, but I'm going to do the other method now. Let's see how we can do. I'll just simplify this. What is 15 into 5 by 15 plus 5? Just if you can tell me very fast, that would be very easy. We'll see. It is 15 into 5 by 15 plus 5 will give me 3.75. So I'll just simplify this. Just look at this. I'm going to simplify this. It is 15 into 5 by 15 plus 5. It is 75 by 20. It is 3.75. Karthik Jilla, hi sir. Hi Karthik. So this is 3.75. So I'm replacing this by 3.75. Now let us replace this by 3.75. Now this is already 10 ohms. You can replace these two resistors by a single resistor because they are in parallel if you observe. Now this can be replaced by another resistor of 8 ohms, and this is 12 ohms. This voltage source is 6 volts plus minus. Now can we say that these two are also in parallel, these two are in series, right? Now I'll just simplify them. That is one more resistor, this is the other resistor, this is one resistor with voltage source 6 volts plus minus. Now let us say this 10 plus 3.5, 13.3.75 is 13.75 ohms. This is 8 ohms. We want just current in 8 ohms, right? We need not bother about the rest of the resistors if they are even simplified. Now if you observe this, this can be, let us say this is 8 double dash, I8 double dash. What is I8 double dash can be written as? I8 double dash can be written as, if I say this is the total current I, total current into opposite branch resistance 13.75 by total resistance 13.75 plus 8. Can I write it in this way? This is one more method, Vijay Dhawan. You can solve by using this method, which is also very easy. Apart from nodal analysis, I think this is also one of the easiest method. Now you need to find the total current. What is the total current? It is voltage by the total resistance. What is voltage? Voltage is 6. Now if you find the total resistance, that is the parallel combination of 13.75 and 8 and 12, that will give you current value 12 plus 5.06. This is 5.06 and 12, it is 17.06. So the current value will be 0.35 amperes. When you know this current, can I find I8 double dash? It is 0.35 into 13.75 by 13.75 plus 8, 21.75. So you'll get I8 double dash value. What is I8 double dash value? It is 0.22 amperes. I think this is one of the easiest method even. 0.22. What was I8 dash? Let me write that I8 dash. So if you find this I2 minus I3, this I8 dash will be 0.096. So finally, what is I8? What was I8? I8 is the current that I have taken in this 8 ohm resistor. So I8 is equal to I8 dash. This is I8 dash 0.096, that is I8 dash, plus I8 double dash. It is a current because of the second voltage source. So I8 double dash. What is I8 dash? 0.096. And what is I8 double dash? It is 0.22. 0.22. So the total current will be I8. Current in 8 ohm resistors using superposition theorem can be I8 is equal to 0.316 amperes. This is what you'll get. 0.316 amperes. Now let me summarize this question once again. Yeah, let me take this question. Just what I have, I'll just tell you what I have done in this question. I'll just tell you what I have done in this. The method doesn't matter. Do not worry about it. So this was the given question for me. I'll just try to do this once again. See, I'll just simplify this and tell you. I have done two things here. One is the case one. Because I have two voltage sources, we have two cases. If you have three sources, you'll have three cases. Now this is case 1, this is case 2. What I have done in case 1, I have taken V1 is equal to 4 volts and made V2 is equal to 0. Assume that V2, it should be replaced by the internal resistance, or the voltage source can be replaced by a short circuit and the current source can be replaced by an open circuit. In this case, I have taken V2 is equal to 6 volts and V1 is equal to 0, and I have assumed it as a short circuit. That means here V1 is active. In this case, V2 is active. By using any of the reduction methods, it can be a mesh analysis, it can be a nodal analysis, it can be a reduction technique, it can be a current division rule, it can be a voltage division, any method that you can follow, but you must be very careful and you must feel very easy. G Balraj, hi sir, hi Balraj. So V1 is active and V2 is active. Now V1, when V1 was active and V2 was 0, when I made this as short circuit, I have found what is current IA dash. That is a current in 8 ohm resistor produced by 8 ohm resistor by V1. Now then in case 2, when I have considered only V2 and made V1 0, I have calculated what is I8 double dash. The current in, what was I8 double dash? Current in 8 ohm resistor, current in 8 ohm resistor by V2. Then finally what I have done is I8 is the total current that I have assumed, because the response, I8 is the response in the element. That is what I have assumed. I8 is the response in the element. I8 is equal to, what is superposition theorem? It is the response in any element. This is the response in an element, that is 8 ohm resistor. This is the response in an element is the sum of, that is plus of, sum of the responses caused by the individual sources. This is one individual source. Here also we have considered individual source. The response because of this individual source is I8 dash. So this is I8 dash, and the response due to the second individual source is I8 double dash. So this is I8 double dash amperes. This is what we have done. Casper, hello, hello, hello. Yeah, hello, who's this? All right, done. Thank you for joining Circuit Theory Crash Course. Casper, done. So I think you have understood the essence of superposition theorem clearly. Now let us look at one more simple problem and tell you if there is a current source, what we will do. Let us consider one problem and let me clearly tell you. The question is find, because we have taken two voltage sources in the previous problem. Now Indu Shubham, hello sir. India Shubham, all right. Shubham, thank you for joining Circuit Theory Crash Course. Today we are discussing superposition theorem and reciprocity theorem. So in find current through 4 ohm resistor. This is the question given. Find the current in 4 ohm resistor. Find the current through 4 ohm resistor. This is the question, and the circuit is something like this. Let us consider this circuit is taken from the Ravi Shar Singh textbook. So this is the circuit. You have a current source here in this case, and let me write the values. So the values are 40 volts, and this was 12 ohms, 4 ohms, and 5 ohms, as well as 3 ohms, and this is 8 amperes. Now let us try to solve this very fast, quick, so that we'll also be able to discuss what is reciprocity theorem. Chalo. Now what is the question? First let us understand the question. What is that? Find current I, you have to find through what? 4 ohm resistor. So let us consider that 4 ohm resistor current as this is the 4 ohm resistor current. Now let us consider, sorry, let me consider this current like this as I4. Let us consider this current as I4, 4 ohm current in 4 ohm resistor. Now let us consider the cases, two cases. First case is case 1. What is the case 1? How many sources are there? First you need to write that, right? So let's write the sources. How many number of sources are there? How many number of sources are there? Number of sources is equal to how many number of sources are there? You have two. What are they? One as voltage source V1 is equal to, let us call it as 40. Let us call it as V instead, because we have only one voltage source V. And there is another current source, right? What is that current source? I is equal to 8 amperes. So what is the case 1 now? What is the case 1? Case 1 is when only one source you have to consider, right? V is equal to 40 volts is active. And what about the second source? You need to make the second source must be replaced by the internal impedance or make it zero simply, you can say, and that becomes, because this is a current source, it will become an open circuit. It will become a open circuit. You have to remember this. Now let us draw the circuit. Let me draw the simplified circuit for this case one. Now what is that? You have a voltage source and a resistance, one more resistance here. This is the other resistor, and these are the resistors, and this is an open circuit, so you need not draw that. That 8 ampere current source is removed. Now if this is the case, and this is 40 volts, and this is 12 ohms, 4 ohms, 5 ohms, and 3 ohms. Now simply you can say that if this is the total current I total, and this is I1, and this is I2. So because these 4 and 3, 4, 3 are in series, you can say 4 plus 3 is 7. The current through 4 and current through 3 both are same. And these 4 plus 3 combination is in parallel to 5. So we can write I2 current is equal to total current into the opposite branch resistance 5 by the total resistance 5 plus 4 plus 3. So you don't know what is the value of IT. So find I total is equal to what? V by R total. You need to calculate what is R total. 4 plus 3 is 7. 7 in parallel with 5. So 7 into 5 by 7 plus 5. So 7, it is 12. So 35 by 12 plus you also have another resistor in series. It is 12. Let me tell you once again, 4 plus 3 in series. Sir, please deliver lecture as bilingual that everyone get benefit. It's my request to you, sir. Acha, you want it in Hindi as well or Telugu? If you say it's comfortable in Hindi, the language, I'll also do that in Hindi as well. Yeah, doesn't matter. Don't worry about it. So 4 plus 3 is 7. So 4 plus 3 7 हो गया यहाँ पे. So 4 plus 3 7 and in parallel with 5. So 7 in parallel with 5 क्या होगा? 7 into 5 by 7 plus 5. 7 plus 5 12 होगा. Like 7 into 5 is 35. And this combination is in series with this. That is 35 by 12 plus 12 is what? R total. So that is 35 plus 12 into 12, 144 by 12. That is 179 by 12. So our total value will be, if you calculate the total resistance, it is our total value will be I is equal to V by R. It is 40 by, so it is 12, 14.92 is your R total value. So R total is equal to 14.92 ohms. So ये V क्या होगा यहाँ पे? I total is equal to V by R total, नहीं? So V is what? 40 by R total value is 14.92. So what is the total current that you get? ये total current क्या होगा? 40 by 14.92 will give you 2.68 amperes होगा यहाँ पे. या हिंदी विजय धवन, थैंक यू विजय धवन, डेफिनेटली विल ऑल्सो डू दैट. चलो क्या होगा यहाँ पे? आई टोटल की वैल्यू क्या होगी? 2.68. अभी 2.68 यहाँ पे डाल देंगे आई टोटल के पास, और 5 बाई 5 प्लस 4 9 प्लस 3 12. सो इसकी वैल्यू होगी, आई टू की वैल्यू होगी, क्या होगी आई टू की वैल्यू? 2.68 इंटू 5 बाई 12. क्या होगा आई टू की वैल्यू? 2.68 into 5 by 12 will give you 1.12 amperes. So this is the value of the current. ये क्या हुआ? I2 current. इसको I2 और यहाँ पे क्या बोले? I4. So this is nothing but this current. This I2 is the current flowing in this 4 ohm resistor that we have taken it as I4. Now I4 is this I2 plus the other current. The current because of 40 volts is I2 that we have taken, right? चलो इसको मान लेते हैं I2. ये I2 क्या है? क्या हुआ अभी? It is a current that is being flowed in this 4 ohm resistor because of this 40 volts. Now let us consider the second case. अभी second case ले लेंगे. Now चलो इसको we'll take it in a second slide. अभी इसको, now what is the second case? Case 2 क्या होगा अभी? What is case 2? I want you guys to tell me. अच्छा, मैक्सिमम कैंडिडेट्स कनेक्ट विथ हिंदी बैकग्राउंड सर. चलो ठीक है, कोई बात नहीं. मैक्सिमम कैंडिडेट्स हिंदी में तो हिंदी में बोल देंगे, कोई दिक्कत नहीं है. सो चलो देखते हैं केस 2 क्या है अभी. Yeah, but English is one language that everybody understands. Although, as you are requesting, I'll definitely do that, Vijay Dhawan. Thank you so much for your concern and suggestion. चलो केस 2 क्या होगी अभी? What is केस 2? केस 2 हुआ कि करंट सोर्स ले लेना है यहाँ पे, I इज इक्वल टू 8 एम्पियर्स, और वोल्टेज सोर्स क्या होगी? 0. दैट मीन्स ये शॉर्ट सर्क्यूट होगी. तो अगर ये वोल्टेज सोर्स 0 हो गया और करंट सोर्स इज एक्टिव, ये करंट सोर्स एक्टिव है अभी. नाउ चलो देखते हैं ये वोल्टेज सोर्स क्या होगी? शॉर्ट सर्क्यूट. लेट अस ड्रॉ दिस हियर. इसको शॉर्ट सर्क्यूट कर दिया मैंने, ये वोल्टेज सोर्स को शॉर्ट सर्क्यूट कर दिया, और ये रेसिस्टर ले लिया यहाँ पे 12 वोल्ट्स की, और ये 5 ओम रेसिस्टर विल बी एज इट इज. एंड लेट मी अरेज दिस एंड ड्रॉ दिस. चलो इसको अभी ये ले लेंगे, और दिस इज द रेसिस्टर, और खाली एक 8 एम्पियर करंट सोर्स इज एक्टिव. ये 8 एम्पियर करंट सोर्स एक्टिव है यहाँ पे. नो चलो लिखते हैं इसकी रेसिस्टर वैल्यू 12 हो गई, इसकी 4, और ये हुआ 5, एंड ये हो गए 3 ओम्स. चलो अभी व्हाट यू नीड टू फाइंड? यू नीड टू फाइंड द करंट इन दिस. Now let us just simplify this. What is this resistor? I'll just simplify this because we don't need these resistors to be parallel, and also our task is to find 4 ohm resistor में current find out करना खाली. So इसको क्या लिख सकते हैं? 12 into 5 by 12 plus 5. ये लिख सकते कि नहीं? Because they are in parallel. Vasanta. Oh, thank you for joining this session on circuit theory. I'll be dealing completely control systems course on Unacademy app. You can join me there. We'll also have some special classes there, so I'll just discuss about that probably tomorrow. I'll just tell you that. Chalo, what we are writing? We were writing कि ये यहाँ पे 12 into 5 by 12 plus 5 लिखते हैं यहाँ पे. So it is 60 by 17, और ये we'll just try to draw this once again. Now चलो ये लिखते हैं. देखो यहाँ पे क्या हुआ? ये 8 एम्पियर्स हो गया. दिस इज 8 एम्पियर्स. ये क्या हुआ? ये 4 ohms, और ये 60 by 17 will give you, what is that? 60 by 17 will give you 3.53. 3.53 ohms हो गया है, ये क्या हुआ 3 ohms. Now this is the total current, right, and it is splitting into two parts. क्या लिख सकते हो यहाँ पे? So let us consider this current as I2 dash. चलो लिखते हैं what is I2 dash. I2 dash is equal to total current into, ये branch की opposite branch क्या हो गई 3 by total current. What is the total current? Sorry, total resistance 3.53 plus 4 plus 3. Now but you do not know what is I total. Yes, we know I total. What is 8? So 8 into 3 by 4 plus 3, 7 plus 3, 10.53. सर अभी सही है, थैंक यू. अच्छा चलो ठीक है, कोई बात नहीं. चलो आई टू डैश क्या होगी अभी? आई टू डैश इज इक्वल टू आई टोटल वैल्यू है कि 8 बाई 3.53 प्लस 4 और 3 हो गई. सो 8 इंटू 3 by 10.53 will give me 2.28 amperes. And now you have to be very much careful. क्या I2 डैश की करंट डायरेक्शन कौन सी है? I2 डैश जो मैंने लिया उसकी डायरेक्शन हो गई राइट से लेफ्ट को. नो I2 डैश I2 जो लिया मैंने यहाँ पे, इफ यू ऑब्जर्व दिस I2, यहाँ पे I2 जो देखो, यहाँ पे I2 है देखो, एंड इट इज फ्रॉम लेफ्ट टू राइट. बोथ आर इन ऑपोजिट डायरेक्शन. चलो देखते हैं I2 एंड I2 डैश बोथ आर इन ऑपोजिट डायरेक्शन. I2 हुआ राइट लेफ्ट से राइट और I2 डैश हुआ राइट से लेफ्ट. चलो इसको लिखते हैं अभी. देर इज अ रेसिस्टर हियर एंड इन दिस रेसिस्टर इस पे क्या हुआ, दो करंट है. वन इज I2 एंड द अदर वन इज I2 डैश. सो I2 की वैल्यू क्या हो गई? I2 की वैल्यू क्या है? व्हाट इज I2 या I2 देखो यहाँ पे, दिस I2 इज 1.12 एम्पियर्स. 1.12 एम्पियर्स. और I2 डैश की क्या वैल्यू है? I2 डैश की वैल्यू हो गई 2.28 एम्पियर्स. 2.28 amperes. Now what I have done, I have taken I4 in this direction, or you can also take I4 in this direction, doesn't matter. But कौन सी भी ले लो, just have to consider one and just take it. Now चलो लिखते हैं I4 which I have considered. I4 is equal to, I2 is in this left to right minus I2 dash is in opposite direction. So इसका क्या होगा 1.12 it is 1.12 amperes I2 dash minus 2.28 amperes और क्या होगी ये? It is 1.16 amperes नेगेटिव. अगर ये राइट से लेफ्ट को 1.16 हो गई, what is I4 if I take it, let's say this is I4 dash. I4 dash value क्या होगी? I4 dash is equal to 1.16 amperes and the direction of this I4 dash is from right to left and the direction of this I4 is from left to right. ऐसे लिखना. Yeah, 1.16 negative. That's correct, Vijay. That's absolutely correct. Chalo, I think you are very much pretty perfect with this concept of superposition theorem. अभी चलते हैं reciprocity theorem के. As reciprocity theorem, now चलो लिखते हैं reciprocity theorem. टाइम काफी कम है. Let's try to do it very soon. Reciprocity theorem. Now, what does reciprocity theorem state? So reciprocity theorem, just now we have seen superposition theorem, and what does superposition theorem state? Superposition theorem ये state करता कि response in any element is the sum of the responses caused by the individual sources. अभी ये reciprocity theorem क्या हुआ? Reciprocity theorem, you can take reciprocity theorem something like this. In a linear bilateral network, चलो लिखते हैं इसको. Just be with me. In a linear bilateral network, with single source, the ratio of response to excitation will remain same even if Hello, Anup Sagar. I think you are late. Welcome to Circuit Theory Crash Course. We are dealing with superposition theorem and reciprocity theorem. I have just started reciprocity theorem. Maybe you must have skipped the superposition theorem. Now you just listen to reciprocity theorem. And thank you for joining Circuit Theory Crash Course. In a linear bilateral network with single source, the ratio of response to excitation will remain same even if they are interchanged. Even if they are interchanged. What is this? What is the meaning of this? Let me take one circuit like this, one box. This is a circuit. In this there is a circuit and you have let me take it big. I'll just take it in the next slide. चलो अभी यहाँ पे बोलूंगा मैं what is that exactly. मान लेते हैं कि यहाँ पे एक नेटवर्क है, इसमें इसके अंदर रेसिस्टर और कैपेसिटर्स की एक नेटवर्क है और यहाँ पे मैंने लोड लगा दिया और यहाँ पे क्या हुआ, देर इज ए सोर्स. एंड इसको फिर से और एक केस ले लेते हैं, इसकी और एक केस ले लेते हैं. दैट इज अ स्टेटमेंट एक्चुअली. इसके और एक केस ले लेते हैं. यहाँ पे दिस इज द सेम नेटवर्क पर यहाँ पे कुछ डिफरेंट करेंगे यहाँ पे. चलो देखते हैं क्या है इसकी एक्चुअल एसेंस ऑफ दिस नेटवर्क. सो मान लेते हैं कि ये कुछ नेटवर्क है. ये सेम नेटवर्क जो है ना, यहाँ पे भी सेम नेटवर्क है वही. what we are doing is we are connecting a source here. let's say V1 at these terminals A and B. इसको मान लेते हैं A and B टर्मिनल्स और इसको मानते हैं C and D टर्मिनल्स. यहाँ पे जो है ना, यहाँ पे V1 सोर्स लगा दिया यहाँ पे इनपुट के और यहाँ पे लोड है यहाँ पे. और यहाँ पे जो करंट है ना, यहाँ इसकी ब्रांच CD ब्रांच, इसको बोलते हैं CD ब्रांच. चलो बोलेंगे इसको CD ब्रांच है. इसका जो करंट है, लेट अस कॉल दिस एज करंट I नॉट. Now if you take this, find this response or V1 by I naught or I naught by V1, kuch bhi, you can take either the way. Now if this ratio will remain same when you interchange the positions of this excitation and response. और ये excitation और response की अगर places interchange भी कर दिए तो then the ratio will not change. That is the reciprocity theorem. क्या अगर that means the voltage source here is connected between A and B. इसको यहाँ पे C and D के पास में लगा देंगे. We'll connect this voltage source V1 to these terminals across CD. और ये भी जो है ना, यहाँ पे लोड कनेक्ट कर देंगे. जो भी लोड है ना, वहाँ पे ये लोड यहाँ पे कनेक्ट कर देंगे. और इसको what we'll do is, यहाँ पे करंट जब फंड करते हो ना I नॉट, this ratio of V1 by I naught or I naught by V1 will remain same. This is what is reciprocity theorem. The response to excitation ratio will remain same even if the places are interchanged, even if they are interchanged. That is the problem. So let's say there is something like this and at this load you'll just connect it, and if you are finding current here, इसको यहाँ पे लोड यहाँ पे रख देंगे. या इवन इफ यू चेंज दिस, रेस्पॉन्स यहाँ पे फाइंड करेंगे, सोर्स यहाँ पे देंगे, यहाँ पे सोर्स लगा देंगे और यहाँ पे रेस्पॉन्स फाइंड आउट करेंगे. रेस्पॉन्स इज नथिंग बट द करंट. यहाँ पे करंट फाइंड आउट करेंगे. यहाँ पे लोड जैसे भी रहने दो, यहाँ पे रह सकते हो, यहाँ पे भी रह सकते हो. यू कैन जस्ट टेक द करंट हियर. इफ यू फाइंड दिस करंट, दैट विल बी सेम. So in a linear network, just in a linear bilateral network with a single source, or the ratio of response to excitation will remain same even if they are interchanged. Srinivas Bukya, welcome to Circuit Theory Crash Course, Srinivas. Now चलो अभी लिखते हैं. What we'll do is we'll take one problem and let's see that how does this affect. We'll write one question from the previous university's question. Calculate, इसकी calculate current in, the question is calculate current I and ये हुआ question. Verify reciprocity theorem for the network shown. This is the question, and let me draw the network that I have taken this from this textbook as the voltage source. there are two resistors connected here, and there is another resistor in series and a resistor in parallel at last. So the value of this voltage source is, let's say, 20 volts, और इसकी value हो गई 5 ओम, और इसका हुआ 4, और ये हुआ 10, and this is 6 ohms. It is fine. चलो अभी क्या करना है, इसको वेरीफाई करना है. इसकी करंट दिया गया यहाँ पे as I. Now let us apply reciprocity theorem. I'll tell you one step by step how do you apply this reciprocity theorem. क्या करते हैं? Now what we'll do is, we will find in case 1, we will take two cases. I'll tell you what are the two cases here itself, and then I'll will solve this problem. पहले क्या करते हैं, what we'll do is, this is, we'll find current before interchange. Will not interchange this 20 volts to the load right now. Before interchange, we will find what is the value of the current. Now in the second case, what we'll do is, after interchange क्या करते हैं यहाँ पे, we'll interchange this voltage source here, and current will try to find in this branch. It's not completely taking off the load to this, it is just finding the current response in this branch. In this case, I have told you that this load is, no, this is not actually taken here, we are finding just the current. The load will be here itself. So when you before interchange बोलते हो, ये circuit as it is लगा सकते हैं यहाँ पे. You can just take this circuit as it is and find the value of the current. It is simple parallel network, you can do it. Now after interchange बोलते क्या करते हैं, you'll change that and find I1 dash. And when you take this I by V ratio here or I by V ratio here, this will remain same. Both ये जो both values है ना, ये same रहेगा. This will be same. चलो देखते हैं अब, लेते हैं इसको नेक्स्ट स्लाइड पे और कैलकुलेशन स्टार्ट करते हैं. चलो ये हुआ सर्क्यूट हमारी, और केस 1 ले लेंगे पहले. व्हाट इज द केस 1 दैट आई हैव टोल्ड यू? क्या होगा केस 1? केस 1 होगी बिफोर इंटरचेंज. चलो बिफोर इंटरचेंज. बिफोर इंटरचेंज एज आई टोल्ड यू द सर्क्यूट विल बी सेम. सो इसको डिस्टर्ब करने की कोई ज़रूरत नहीं है. आई जस्ट ड्रॉ इट वंस अगेन, यहाँ पे ड्रॉ कर लूँगा बिकॉज ये सर्क्यूट अगली बार केस 2 में यूज़ होगी हमारे को. सो लेट अस कंसिडर दिस, एंड ये हुआ सर्क्यूट. चलो इसकी वैल्यूज लिख देते हैं. 20 वोल्ट्स हुआ, ये 4 ohms, ये हुआ 4 ohms, 5 ohms, और ये 10, और ये 6, एंड दिस इज द करंट. ना चलो फाइंड आउट करते हैं करंट की वैल्यू क्या हो गई. इट्स सिंपल राइट. सो यू कैन टेक दिस एज टोटल करंट, और करंट इन एनी, ये जो देखो ये 4 and 6 हुआ सीरीज में हुआ, और ये 4 and 6 की कॉम्बिनेशन 10 ohms को पैरेलल में है राइट. समझ रहे हो ना. 4 and 6 जो हुआ सीरीज में है, और इसकी कॉम्बिनेशन जो हुआ पैरेलल में होगी 10 ohms को. सो बोल सकते हैं कि ये और ये 4 + 6 और ये 10 दो भी 10 ohm होगी. ये 10 और ये 10 दोनों भी पैरेलल में होगी. चलो फिर से ड्रॉ करते हैं इसको ऐसा कुछ. हाँ देखो, और ये 4 और 6 क्या हुआ, आई होगा. द करंट फ्लोइंग थ्रू दिस ए 4 और 6, ये दोनों में से जो भी करंट जा रहा है वो आई ही होगा. सो इसकी वैल्यू क्या होगी, 10 ohms होगी, बिकॉज 4 + 6 आर इन सीरीज. और ये भी हुआ 10, और ये हुआ 5 एंड 20. हो गया ना बात अभी. चलो ये मान लेते हैं इसको आई टोटल. नाउ व्हाट इज आई टोटल इनटू व्हाट इज द ऑपोजिट ब्रांच टू दिस 10 by 10 + 10. So what is I total? You do not know I total. You need to find, that is V by R total होगी. क्या V की वैल्यू क्या है, 20 by R total की वैल्यू क्या हुई, 10 into 10 by 10 plus 10, ये हुआ 5, और इसकी 5 plus 5 will be 10. So this is 2 amperes. चलो सब्स्टिट्यूट करते हैं इसको यहाँ पे. So it is 2 into what is that, 10 by 20, और ये हुआ 2, और इसकी वैल्यू हो गई 1 ampere. What is the current in this? इसकी वैल्यू आ गई 1 एम्पियर. सो वैल्यू ऑफ करंट बिफोर इंटरचेंज इज 1 एम्पियर. Value of current before interchange is 1 ampere. Now let's take the same circuit to the next slide and try to find. Now let's take the same circuit to the next slide and try to find, apply the case 2. Case 2 क्या हुआ, case 2 will be after interchange current find out करना पड़ेगा. What is that? After interchange. Lakshman, good evening Lakshman, welcome to circuit theory crash course. आफ्टर इंटरचेंज बोलते हैं इसको यहाँ पे लगाना पड़ेगा, और ये करंट ये ब्रांच में फाइंड आउट करना पड़ेगा. लेट अस टेक दिस 2 branches, these as nodes. Will apply this 20 here and find the current here. चलो देखते हैं क्या होगा. ये हुआ 5 और ये 10 ohms, और ये 4 ohms 6 ohms, यहाँ पे लगा देंगे वोल्टेज सोर्स। इसकी वैल्यू हुआ 20 वोल्ट्स और ये हुआ 6, ये 4 ohms है और इसकी वैल्यू 4 5 और 10। करंट यहाँ पे फाइंड आउट करना, विल कॉल दिस एज आई डैश, लेट अस कॉल दैट एज आई डैश। आई क्या, व्हाट इज द वैल्यू ऑफ आई? आई की वैल्यू है 1 एम्पियर एंड दिस इज बिफोर इंटरचेंज। नाउ वी आर गोइंग टू फाइंड व्हाट इज I dash. What is that? I dash is the current after interchange. Now यहाँ से देखना पड़ेगा, यहाँ से देखे तो क्या होगा? Let us call this current as I total and this as I1 dash. Now these two are in parallel if you simply observe. चलो, what is I dash? I dash is one current in the parallel branch. It is I total into opposite branch की resistance क्या होगी? अगर we are finding current, ये 5 ओम में फाइंड आउट कर रहे हैं ना करंट, इसके ऑपोजिट ब्रांच होगी 10, सो इसको लिखते हैं 10 प्लस 5 लिखना है यहाँ पे, बिकॉज दिस टू आर इन पैरेलल। चलो, इसकी वैल्यू क्या होगी? वी नीड टू फाइंड आई टोटल फर्स्ट। व्हाट इज दैट? वी बाई आर टोटल। व्हाट इज द वैल्यू ऑफ वी? 20। आर टोटल की वैल्यू क्या है यहाँ पे? लिखो जरा, आर की वैल्यू लिख देंगे यहाँ पे। सो 5 इंटू 10 बाई 5 प्लस 10 वैल्यू होगी ये इन दोनों की। सो इट इज 50 बाई 15, इट इज 5 3 ज़ा 5 10 ज़ा 10 बाई 3। चलो देखते हैं, इसकी 10 बाई 3 हो गई इसकी कॉम्बिनेशन, और you have two more resistors in series, so इसकी value है 10 और 6 plus 4 is 10 and this is 10 by 3, so it is 10 by 3 plus 10, it is 40 by 3. So this value is 40 by 3, इसको लिख सकते हैं 20 by 40 into 3 लिख सकते हैं कि नहीं? This you can cancel out and 2 1s are 2 2s are, it is directly, हाँ देखो यहाँ पे 2 1s are 2 2s are 3 by 2 है कि नहीं? 3 by 2 amperes. चलो लिखते हैं यहाँ पे, it is 3 by 2 into 10 by 15. Then you will get it as I dash. What is I dash? I dash की value क्या होगी? What is the value of I dash? When you interchange, the value of current will be the same, 1 ampere. Now if you take the ratio of responses or not, that doesn't matter। यहाँ पे देखो 1 by 20 सेम और 1 by 20 ये भी सेम हुआ, therefore the reciprocity theorem is verified। What is that? The reciprocity theorem is reciprocity is verified। यहाँ पे 1 एम्पियर, यहाँ पे भी 1 एम्पियर। I hope this is very clear for you now. So we have discussed what is सुपरपोजिशन थ्योरम, इसमें लिखे हैं सुपरपोजिशन थ्योरम, और यहाँ पे इट इज, और क्या किया आज हमने? इट इज रेसिप्रोसिटी थ्योरम। वी हैव डन 2 थ्योरम्स फॉर टुडे, वन इज सुपरपोजिशन थ्योरम, अदर वन इज रेसिप्रोसिटी थ्योरम, और इसकी प्रॉब्लम्स किए हमने, और वी हैव आल्सो डन problem on reciprocity theorem. If you want more number of problems, you can also watch my lectures on Unacademy app as well. Thank you all. Thank you once again, Lakshman, Srinivas, Anup Sagar, Vijay, Dhawan, Vasanta, Shubham, Casper, Balraj, Karthik, Jilla, and Srishti Imitation Jewelry, Soumya, Augustus, Balla, Raju, Manoj Kumar, Ramchandra, Pavitra, Ganesh, Manasa, Jilla, Sanjana, Matthew, Swarnasri, Srinivas, Piala, Mulkala Koteshwar. Once again, thank you all for joining me today for this beautiful session on superposition theorem and reciprocity theorem. I'll be starting the next topic in the next class. Please do join me for the next class at 6:45 p.m. tomorrow. Thank you once again. And as I always tell you, we have India's #1 study channels, Creatrix Gate India, Unacademy Gate ME, PIXE, and Unacademy Gate CE, Unacademy Gate Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy Gate Questions, Electrical Junctions, Unacademy Foundation, Engineering Pathshala, and Unacademy Semester Exams. Please do like this video, share this video. You can use my code to get the maximum discount of 10%, and please do subscribe and click on this bell icon to get notification of my classes. Once again, thank you all for joining me today for this session on superposition theorem and reciprocity theorem of circuit theory. Thank you all.